quick way to tackle these kind of intro problems. You are welcome. I suggest that you grab Microsoft Excel or get Google Sheets or something like that, but hopefully Microsoft Excel, and then take this word problem and kind of do this parallel with me. This video doesn't take long. You're welcome to just watch it and kind of record it and then submit it to me that way. I just want to make sure you walk through this process before we get to class so that it's that much easier. And if you turn it in to me, I'll give you credit. I won't investigate how it went about, but take the time to really work this out, and it'll pay its dividends down the road, so to speak. So here's the problem. This is just a random type of problem. There's a performing arts hall, and there's this 400-seat auditorium. This will kind of mimic the project that we actually do. So the process is important. So if there's a price, you guys know that setting a price for something determines how many people are willing to show up. That is, in essence, what demand is. What people are willing to pay for a particular item is different. Everybody has their threshold for what things are worth. And so we come up with a model or an equation that says, you can expect this many people to attend or buy something if the price is this amount. And that's what we're going to do in class on Wednesdays. We're going to collect our own demand data on something, and then we'll make our own demand curve. But this is the preface to that. So if you guys go into and download this Word document, one of the cool things about the Word document form is if you just copy that table, you can actually paste it right into Microsoft Excel, and everything's groovy. The only thing about this is that when you do it that way, it's backwards. So I'm going to show you a couple tricks. When we plot this data, which is actually something that we're going to do, we have the price on the left and the attendance on the right, and that's actually backward what we want. So one is go fix it in Excel. I would just take and highlight that particular, swipe down the middle, the price piece. And if you use the cut and paste option from the edit option, or open Command X, I'm going to cut and paste and put it on the right hand side. You want to invert those. The other option is to, when you copy and paste them, copy one column at a time. So copy this one, paste it over, copy and paste. There. Then it should look like this on the other side, whether it has these darkened, boxes or not. The cells are darkened or highlighted. Don't worry about that. What we need to do now is graph this, just like we had in the past. You just want to swipe and highlight down the middle, and you go to Insert on Excel, and you grab your scatter plot wherever it happens to be. No connections or anything, just XY scatter, and there it is. There's our plot. The next thing we did, if you remember from our past Excel experience, is you right-clicked or command-clicked if you're using a Mac, and you go to a trend line, add a trend line. And when you do that, you get these options, and I got to move my screen over to form some type of trend line. What we're going to do here is I think I make a suggestion. It says fit a quadratic and linear model to this data. So we're going to do linear, and then quadratic would be a polynomial of order 2. So if you actually clicking on it, you can kind of see both of them fitting right now. There's linear and then polynomial order 2, and you can see the graph changing in there. I just want to know both of those. I want the equation that goes with it, which means down at the bottom of your format trend line, you want to display the equation chart of some kind. And actually, you might want to eventually display this r squared value that goes with it. I'm going to leave it off for now just for simplicity. So there's my linear model. I actually want to grab that. If you do a copy, you can actually highlight that linear equation and copy it and then paste it over here. So when it asks for what's the linear model, I can actually just go in there and actually paste it in there, which is great. So that gives me my first piece. And you can handwrite it. You're welcome to, and try and scan it to me. But if you want to type it, which is always cool, I think, go for it. Down below, I'll do another one. Let's do our quadratic. So when I'm over here and formatting my trend line, I can go in. So I can start over. I'm going to right-click, start fresh. Just go click on a data point that's in there. So if I click on one of my data points and hit right-click, it says format my trend line or add a trend line. Either one's fine. But I want my polynomial order 2. And I want to click on it and highlight that equation, or handwrite it, or however you want to go about it, and copy and paste that. There's my quadratic model. Now, when I told you I swapped those two things, we need to know what's on this. What we have is a graph of price on the left and the attendance on the bottom, the number of attendees. So X is going to stand for number of people attending, and Y is going to stand for price. So when I go into my model here, I might even say this is P, or little p. We call it little p for price, and little p for price. And X then stands for, we want to probably explain this, X is number of people attending. That's important for you and for me to understand that. So making sure you make that clear is always a good idea when you're doing this type of modeling. What does X mean? What does P mean? Or what are the input and output variables? What are you graphing is basically what we're after. X is the number of people attending in both cases, so I'm going to copy and paste that down below. Again, you can be kind of entering this in your own special fashion, but I just wanted to give you the idea of how we can use our past skills with Excel that we're now trying to enhance. We just found two models for predicting attendance based on price. So now this model P of X is the demand equation. I'm just reading what's on your sheet, known as price demand. So it's basically an equation that tells you what people are willing to pay. And if you've had econ or are taking econ, you remember demand curves look like this. They're always descending as you read left to right. So the more units that are produced, the price is lower, and vice versa. Fewer units, more rare, the price is higher. And the corollary is also, if you think about price, higher prices usually correspond to fewer being purchased, and lower prices usually correspond to more being purchased. And that's what's being the trend you're seeing in this particular graph. All right, I'm going to move back over here. I just highlighted that what we just found. Now you're supposed to come up with a revenue function. Now, revenue function is actually a really simple derivation of what we just had. All we do, since your price, that P of X function is really giving you a price given the number of units that are sold. Revenue is always how much money you make. It's what you sell it for, the price, which we found in a function, and how many you sell, the price times the number of units that you sell. And that will be what we're seeing here in this revenue function. It's always number of units X times the price you're selling at. Revenue will always be price times number of units. So that's what we're going to do. We're going to make our own little equation. I have math type on my computer. You guys can use other things as well, or use Desmos does a nice job typing this out. But for us, it's going to be X times, if I put this in here, and our P of X. Now, our function, instead of writing P of X this time, what I'm going to write is the actual one that we came up with. So, excuse me, if it's the linear one, I'm going to put that in here as my price. So that was negative 0.1064 X. There we go. So that'd be my linear version. And then down below, I'm going to actually make my revenue in case I use the quadratic. Now, they're two different functions, but the models are just different predictors. And I've asked in the questions, like, which one fits better? You have to justify which one you think fits better. It's your opinion. It's how well you think it demonstrates the data. You need to think about how it fits as well as how well it predicts. Like, do you think the straight line is a good way of predicting what will come in the future? Or do you think that quadratic, the way it kind of levels off or curves, is a better predictor? I didn't finish my linear data. I was talking and didn't write in the plus 51, did I? 51.239. All right, there we go. That's the whole thing. And then the quadratic, I'll just write this in here real quick. Hey, I don't need to do this. Can I just copy and paste it? Probably. So I'm going to go grab that. Sometimes it doesn't like me pasting into this math type thing, so bear with me. If it doesn't print well, it might balk. Did pretty well. So there it is. There's my 0.002. Did a decent job this time. It's funny, sometimes it's agreeable, sometimes it's not. And we'll close it off. Bingo. So those are my two models for this, the quadratic price and the linear price. Both explain price as a function of how many units are sold. And then to get revenue, you just multiply by the number of units. The concept is number of units times the price you sell it at gives you revenue. Now, they're not actual numbers, right? They have X's in here. That's because the number X units, which is, remember, number of people attending this particular concert, the number of people attending will affect the price. And of course, when you multiply by the number of people attending at a given price, it will, that'll be a different number. For every number of people attending, there is this relationship between, hey, there's a price that changes times the number of people that are there to get your revenue. It's dynamic. It's different for every X. That means we want to graph this function and see what are all the possible revenues for every possible X. So we are going to graph this. So there's the picture of it. By the way, I'm going to copy this. I'm going to paste it into this is asking for these things. I'm going to paste it down below. There you go. So now I've answered that question. You're welcome to borrow mine. And then down below, this next question is find the maximum revenue and the corresponding ticket price and average attendance that goes with it. we're going to use Desmos to kind of relieve us from doing too much heavy thinking. I'm going to choose the quadratic one here just because it's kind of fun and it's sitting right in front of me. So I'm going to copy that. I'm going to use Desmos to do the graphing. So we're going to go to desmos.com. Here we go. Start graphing as we often do. I'm going to try and paste it. It's kind of an experiment. Will it work? Will it work? Let's see if it'll work. Paste it. Oh, I can't get it to go in there. Did I copy that? Copy and paste and match style. I don't know what that's going to do for me. I don't know. I guess it's not going to paste for me. Anyway, I'll just write it out as it is. Thought I was going to get some fancy cool thing to make happen in here. R of x equals, and I'm just going to go back and get everything I can. 0.002x squared x 0.002x squared, and none of zeros, did I? Beautiful. Then you go to negative 0.2108 up there, minus 0.2108 minus 0.2108. You have to let me know later on if something funny happens in here. And then plus 64 what was that total? 781. Beautiful. 781. There's our function, our revenue function. Again, tell me if something later on if I have an error, but it looks like I'm good to go. That's the one I have. Now, you notice I can't even see it in the Desmos calculator. The things you want to think about are what type of function are we looking at is always a good thing to think about. Like, how big is this? If I actually multiply this out, which I can, it will be a cubic because x times this. So I'm thinking it's going to have this up and down kind of thing going on here. And if you zoom out far enough, you'll eventually see the graph. Oh, there it is. There's the little up and down dip that happens. And there is an up and down. So how do we interpret this revenue thing? If you look a little bit beyond, some of these things here, this is, you see the peak and you see the valley, which is a cool thing. Because with revenue, we're interested in those things, and Desmos automatically shows them to you. Here's a peak. For x equals 226, that's an attendance in that particular concert. The y is 6182. 6,182. Do you remember what y is? Total revenue. Remember, we're graphing revenue is our output. That means our y coordinate. And x is our input, which is the number of people attending. So that point right there is if 226 people attend, 6,100 is our revenue, and if I go to this next extremity here, 475 people attend, my revenue is 4,600, and if I go way out to some point like out here, where revenue is really high, look at that, I got revenue at 7,000, I only have to have 625 people show up, and I've got a revenue of 6,900 bucks. Well, do you want to think about that for a second? Are all of these reasonable? Do you remember what our problem, if you go back to it? There's always a restriction. In reality, you can never just have, this is a 400-seat house. So when we're looking at these, the bottom one here, that 475, this is 226. You can't even go beyond. So I need to be limiting this to, there's 400 people that can sit here. So I put a little x equals 400 vertical line in there to show you that we're only interested in revenues up to that blue line at 400. And my goal, the question says, when do we maximize revenue? Well, in a graph, all you have to do is look. When does it get to the highest within the reasonable domain of the problem, which is I can have 0 to 400 people in attendance. Well, there it is, that peak right there, 226.9. You can't have fractional people, so let's round up since we want to make sure we kind of count a full person. So we'll go 227. And at 227, it looks like we have 6182-ish as far as our thing. So let's go 6182 is our revenue. Okay, 227 and 6182. That answers this maximum revenue business. So I'm going to go over here and say for 227 people in attendance, the max revenue is, and we had a total of, how much was that? 6182, and that's in dollars, right? 6182. Done. So there you have it. That's total revenue. Now, I didn't talk about what the unit was for revenue, but it's money, right? It's the number of seats times price, so it's a dollar amount. And we've maximized revenue for having 227 people in attendance. Now, Are you wondering what I'm wondering? Like, how much are we charging? 227 people showed up, but we have no idea how much the price is. And so that's the next piece of this. We actually need to take that information and say, for 227 people, I need to know what the price is. Well, we have something for that. If you guys remember, we have created a model.